Hey there, welcome to my YouTube channel. Here, we're all about diving into the latest news and random happenings from yesterday to now. Let's explore together what's buzzing and what's fresh on the scene.
Everything after clearing the tower was icing on the cake. And there, as you saw, as we promised, an exciting end to the Starship inaugural integrated test flight.
The SpaceX Starship will return NASA astronauts to the moon in this decade. Elon Musk and his crew at Starbase are working at ludicrous speed to develop the largest, most powerful, and most capable vehicle ever launched into space. Meanwhile, NASA is preparing a roadmap for the first permanent outpost on the lunar surface. When these two join forces on Artemis 3, we will land on the moon. It won't be easy, but there are some things that are only worth doing because they are hard. And this is how it happens. Why it took so long. Let's talk about some factors that make this next moon landing different from the Apollo mission of the late 60s and early 70s. Typically, the first question that people want to ask is why it's taken so long for NASA to go back. Did they lose the technology to land on the moon? Did they lose the skill or the knowledge to pull it off? Maybe they never even went to the moon at all and just made the whole thing up. The most simple explanation is that NASA lost the money to land on the moon, and they never really got it back. The current annual funding for NASA from the US government is right around $25 billion, which sounds like a lot, but isn't. If we adjust for inflation and stuff, then in the Apollo era of the late 1960s, NASA was receiving something like $300 billion per year. So that's a lot less money to work with in the modern day. And that's how NASA arrived at their SLS rocket and Orion crew capsule, the best they could do with the funding that they had available. And yes, there is a whole discussion to be had about bad project management and cost overruns on the SLS, but not in this video. Essentially, what we're looking at is recycled hardware from the space shuttle graveyard that's been cobbled together into a rocket booster, and then it's topped with a slightly modernized version of the old Apollo command module. For all of its many flaws, the SLS and Orion system can do some pretty amazing things, and we saw that for ourselves on the flight of Artemis 1 as the uncrewed capsule was sent all the way to lunar orbit and back again with no major issues. The real problem is that sending a vehicle to lunar orbit and back is about all that SLS can do. It's missing one very important piece of the puzzle, the landing. And this is where SpaceX comes in. NASA couldn't afford to develop their own lunar lander the way that they had done for SLS. They ran out of stuff to recycle, but they could throw a few $1 billion at SpaceX to buy a lunar human landing system variant of their incredible new Starship rocket, which SpaceX was already developing independently to fulfill Elon's dream of colonizing Mars. So Starship was going to happen with or without NASA's support. If a Starship can land people on Mars, then it can definitely do the same thing on the moon. All it needs is a few modifications to fit NASA's Artemis mission profile. So unlike the SLS, we have yet to see the Starship complete an entire mission profile successfully. But we have seen SpaceX accomplish some pretty amazing things after just 3 attempts, including a successful second stage deployment into just slightly less than orbit. So it's really just the coming back down part that SpaceX is trying to work out right now with Starship going into their 4th flight test. The lunar Starship is a slightly different beast from anything that we've seen so far on the launch pad at Starbase. While the current Starship upper stage is designed to reach low Earth orbit and then come back down to the surface in one piece, the lunar Starship is going on a permanent vacation to the moon. No return trip. So in many ways, this makes life easier because the lunar variant won't need to endure the extreme heat of re-entry into Earth's atmosphere. And that's why it abandoned the signature wing flaps and traded the black heat shield tiles for a sleek coat of white paint. But this does introduce a whole new problem into the Starship equation. The current Starship design can carry somewhere between 100 and 200 metric tons of stuff into low Earth orbit. SpaceX could probably accomplish that with what they have right now. But the problems arise when we try to go any higher, because not only is the cargo inside the Starship incredibly heavy, so is the stainless steel spacecraft itself. And the more weight you are trying to move, the more fuel you require. So just to reach a stable orbit of a few hundred kilometers above the surface, Starship will expend its entire fuel supply. To reach higher altitudes, such as the Moon, Starship will need to be refilled. This is where things get complicated. On flight test number 3, Starship successfully performed an orbital fuel transfer between 2 separate tanks on the same ship. This is a pretty big deal because moving cryogenic fuel from one location to another while in space had never been done before. Now, for their next trick, SpaceX has to move fuel from one ship to another ship, meaning that we are going to see 2 ships in orbit at the same time, so they can link up and dock together. We are going to see this done many, many times before Starship can be considered for landing on the Moon. Here's the deal. A fully fueled Starship upper stage can hold 1,500 tons of propellant, and each ship has the ability to carry something like 150 tons of excess mass into orbit at most. So at this rate, you would need to launch 10 Starships in order to carry enough fuel into orbit to refill just one lunar lander. And this figure was confirmed by SpaceX Vice President of Customer Operations and Integration, Jessica Jensen, as recently as January 2024, on a NASA Artemis update conference call. When pressed for a number, Jensen said that it will take roughly 10-ish Starship launches for a single mission to the Moon. So let's imagine that the whole orbital refilling situation all goes according to plan. Elon Musk seems to think it will be pretty easy, and he does make a good point on this one. If a SpaceX Dragon can dock with the ISS, even though they are using totally different systems that can't talk directly with each other, and it shouldn't sound crazy that 2 SpaceX-controlled Starships would be able to accomplish the same thing. Now, the first Starships to land on the Moon will not carry any people on board. A big part of the NASA requirements for considering Starship to be safe will be an uncrewed test landing. The idea right now is to send a skeleton Starship for the first touchdown on the Moon, basically an empty test vehicle that just needs to prove the landing system works. This is according to NASA. Although on that same conference call from earlier this year, Jessica Jensen also clarified that the first lunar Starship will land and then ascend off the surface on the same mission. Initially, this test had been planned for 2024, which was very ambitious. But we are holding out hope that it could happen by the end of 2025 or early 2026. If that all goes to plan, then the second lunar Starship will be the real deal. It's going to be fitted out with a crew compartment that will keep 2 people alive on the Moon for up to a week, plus a cargo bay that will hold the EVA suits and equipment for exploring the lunar surface. If everything we've just said actually happens according to plan, and if the SLS and Orion can successfully complete a crewed mission to lunar orbit and back on Artemis 2, then we get back to the main event, Artemis 3. This could happen in 2026. It will be preposterously difficult to achieve, but it can be done. So let's go with that. It's very likely that the HLS lunar Starship will be constructed and launched from the SpaceX facility at NASA's Kennedy Space Center on Cape Canaveral, Florida. Starbase is cool, but I think it's safe to assume that NASA wants to be a lot closer to the development of their next lunar lander and keep it side by side with the SLS. So this is what SpaceX is already preparing for at their Florida launch site. The Starship goes to orbit uncrewed. It refills at the orbital propellant depot, and it sets course for the Moon. The Artemis missions are going to use a distant retrograde orbit around the Moon. So instead of getting in close and circling around, they are going on a long oval-shaped path that gets them very close to the Moon's south pole, and then goes way out into space, and then back again. This is more fuel efficient for the spacecraft and the eventual lunar gateway station. While the lunar Starship settles into orbit, the SLS is prepped for launch with 3 crew members on board. The Orion capsule will make its way to rendezvous with Starship in the same lunar orbit. Could we have just sent everyone in the Starship to begin with? Maybe. but I'm not convinced that one lunar Starship would have enough fuel to get from low Earth orbit to the surface of the moon, and then all the way back again on one tank. I think you'd probably need a second refilling on the moon, and that would probably be more complicated than just using the Orion. But that's, again, a whole other video. When the two spacecraft finally meet up, they need to dock nose cone to nose cone. This isn't ideal, but it will have to do until we can get the Lunar Gateway Station up and running. With 2 crew members on board, the Starship is going to release from Orion and head towards the lunar surface. To do this, it's probably going to use a burn from the main Raptor engines. This will slow the ship down enough to be caught in the gravity well of the moon and pulled into the surface. From here, it looks like the landing controls are going to be handled by a new set of thrusters that are unique to the lunar Starship. They are mounted a little more than halfway up the body, and that makes sense for a couple of reasons. Since the gravity on the moon is so low and the Raptor engines are so powerful, it's probably too much, even at minimum throttle, for a soft touchdown. Also, using a landing engine at the base of the rocket would kick up a giant dust cloud and disturb the entire landing zone. With smaller and more precise thrusters higher up on the ship, you get a more controlled and stable descent. Remember the Intuitive Machines lander that tipped over on the moon recently? It was also tall and narrow like a Starship, so tipping over will be a big concern with a vehicle like this. There's not much gravity holding you down, but moving the thrusters closer to the ship's center of mass and pointing them out at an angle will help a lot to keep it stable and prevent any sideways momentum. The landing thrusters will bring the ship in for a slow and gentle touchdown, just like a helicopter. This will be the first fully automated human landing on the moon. The old Apollo astronauts had guidance computers, but they weren't particularly accurate. So achieving a safe touchdown required the skilled hand of an experienced pilot. This will not be the case for Artemis. Just like a Crew Dragon vehicle, Starship won't have manual controls, only big touchscreens to monitor the ship's flight status. So we are putting a lot of faith in SpaceX to get this right. But again, assuming this all goes right, then we have 2 NASA astronauts who are only an elevator ride away from setting foot on the moon for the first time in this century. The first of many more footprints to come. April 20th, 2023. SpaceX's ambitious Starship rocket embarks on its maiden voyage, a journey destined for both the skies and the history books. But what seemed like a flawless liftoff quickly turned into a spectacular display of successful failure. In a scene that captivated the world, SpaceX's new Starship rocket met its end just moments after takeoff. But to Elon Musk and his team, this wasn't a setback. It was a critical step forward. According to aerospace experts like Garrett Reisman, former NASA astronaut and advisor to SpaceX, this successful failure is a testament to SpaceX's daring approach in aerospace engineering. Elon Musk himself, CEO and chief engineer at SpaceX, praised the test flight for achieving its primary goal, gathering invaluable data to advance the Starship's development. Tanya Harrison, planetary scientist and fellow at the University of British Columbia, highlights the inherent risks in developing cutting-edge rocket technology, emphasizing that every test, successful or not, propels us closer to our interplanetary dreams. Since its founding in 2002, SpaceX has redefined space travel with its Falcon 9 rockets, launching numerous commercial missions into low Earth orbit annually. With Starship, SpaceX aims to revolutionize space exploration, envisioning missions to Mars and beyond, carrying not just astronauts but entire lab facilities and tons of cargo. Despite the fiery end of Starship's maiden voyage, SpaceX continues to push the boundaries of what's possible in space exploration. As Elon Musk once said, "Failure is an option here. If things are not failing, you are not innovating enough."
You just wanted to get people interested in space again?
Yes, yeah.
Capture the imagination?
Yes, that was the idea.
You know, there are American heroes who don't like this idea. Neil Armstrong, Gene Cernan have both testified against commercial spaceflight in the way that you're developing it, and I wonder what you think of that.
was very sad to see that, because those guys are, yeah. You know, those guys are heroes of mine, so it's really tough.
They inspired you to do this, didn't they?
Yes.
And to see them casting stones in your direction.
It's difficult.
When you had that third failure in a row, did you think, I need to pack this in?
Never.
Why not?
I don't ever give up.